present to you John Stone. Dr. John Stone, thank you.
No, I can just do this. That's not my presentation. There we go. Can you see that, everybody? Well, yes, it's been a rather exciting day. It's not every day you wake up in the morning and told that you've been part of a Nobel Prize, although it's not the first time for me, actually. I came to Canada as a postdoctoral fellow at the National Research Council, and the year that I was there, Gerhard Herzberg won the Nobel Peace Prize, won the Nobel Prize for Chemistry. I was part of his research group at the time, so by association only. So thank you very much for inviting me to this conference and being able to talk about climate change. Climate change is an issue that has generated considerable political and media interest, lots of sound and sometimes fury, but not always signifying very much. It's an issue with an almost continual round of international meetings, lots of jet fuel and great promises, but is yet very little real action. It's an issue which, despite significant progress, and where action is increasingly urgently required, has been addressed with only modest, effective political effort over the last decade. It's an issue that can be simply understood, but yet represents possibly one of the greatest scientific challenges of our time. It's an issue of morality, where actions today and in one country will benefit people on other shores and of future generations which we may not meet. And an issue which sometimes defies simple economic accounting. It is, in short, an issue which will not go away. Let me begin at the beginning, to quote Alice in Wonderland. It's been known for a long time that the presence of certain gases in the atmosphere create conditions that allows for human civilization to exist on this planet. These gases are known collectively as greenhouse gases, and they act like a blanket around the Earth. They trap heat and raise the temperature of the Earth by as much as 33 degrees Celsius, making this planet habitable for us. They therefore significantly affect the climate. And this diagram, which I'm not going to go into all the details, reflects some of the well-established physics behind the whole idea of the greenhouse effect. Now, the climate has always changed, but it's been mainly driven by the path of the Earth around the Sun in a slow and predictable manner. But by contrast, the changes we have seen recently have been unusually rapid and of other causes. We have seen evidence of these changes in physical and biological systems, such as the shrinking almost everywhere of alpine glaciers, the lengthening of the growing season, and the decline of the extent of the Arctic sea ice, about which I'll have a lot more to say later. And we have good evidence that the changes are caused mostly by the increase in the concentrations of greenhouse gases in the atmosphere as a result of human activities, primarily the prolific burning of fossil fuels. Now, a little bit about the past. When we look back over the past half a dozen or so ice ages, we can see that we have now taken the atmospheric concentrations, the atmospheric composition, particularly of carbon dioxide, into levels that we have not known for almost the last 1 million years. Now, this diagram is a little complicated. It shows the results from an ice core that was drilled into the Antarctic ice sheet. It was 3 kilometers long. Every year when the snow falls and is compacted, it holds within its crystals, clearly, samples of the ambient air. And every year, these things are driven further and further into the ice sheet, but remarkably, they stay intact. So if you drill right through and look at this ice core, you can see slice by slice, year by year, what the composition of the atmosphere was at the time that the snow fell, and by proxy, what the temperature was. And that's shown on here. So here is temperature, which is, as a proxy, we're using a hydrogen isotope. And this is what's happened to methane, and this is what's happened to carbon dioxide. Now, the important thing in this graph is that if you see, for example, the CO2, the carbon dioxide, over the last, and this is 600,000 years, we can actually take it back further, and every one of these blips here is an ice age, that the level of CO2 in the atmosphere has stayed between about 200 and about 280 parts per million. It's now up to 380 parts per million. So we've clearly taken the atmosphere into uncharted territories. And it's because of this unprecedented increase in carbon dioxide and other greenhouse gases in the atmosphere, and also because of our understanding of the influence of these greenhouse gases on the climate, that I refer to climate change as a threat. We may not be able to predict exactly how the climate will change, where it will be felt most acutely, or when. However, we do know enough to realize that change it will, and to recognize that the threat of climate change is real, and that we must act, and we must act sooner rather than later. So what have we seen so far? Let's look at the temperature record. And this diagram shows a reconstruction of the annual surface temperatures averaged over the whole of the Northern Hemisphere over the past 1,000 years. So here's the year here, and this is the temperature. But it's an average temperature. In the recent period, which is when we've actually had thermometers, you see it in red here. And then before that, we've got to rely on what we call proxy data, which is things such as tree rings and ice cores and all the rest of it. Clearly, as we go further back in time, the uncertainty increases, which is the grey shading. But what you can see is the modern day temperatures are not only higher than the proxy estimates, but also outside the bounds of the range of uncertainty. This is the famous hockey stick that the skeptics like to criticize. This is a diagram from the third IPCC assessment. There have been many similar reconstructions since then using different data sets and using different methodologies, but the basic shape of a hockey stick is present in all of them. And this led the IPCC to conclude in its recent assessment that warming of the climate system is now unequivocal. It is without question. And this is a quote, actually, from that IPCC report. But it's worse than that, in some ways. So here is a plot of temperatures over the last 1.5 centuries, going back to about 1850. And the black dots are the global mean temperature for each of those years. And the blue curve kind of gives us a sense of the uncertainty for those measurements. But the point to raise here is that you can't really draw a straight line through all of those dots very easily. But if you go back over 150 years and you try to draw as well as you can a straight line through all the 150 years of data, you get the red curve. If you do the same over the last 100 years, you get the purple. For the last 50 years, you get the brown. And if you do it for the last 25, you've got the yellow. And what must be very clear to you is the closer we're getting to the present day, the steeper is that curve.